Bismillah ar-Rahman ar-Rahim. So last time we started to talk about transport layer protocols. We talked about two major functionality of any transport layer protocol. The first one was the multiplexing and demultiplexing. And we mentioned that this is the basic and minimum functionality for any transport layer protocol. Without this, you cannot call any protocol a transport layer protocol. So it has to have multiplexing and demultiplexing, and this is facilitated through the use of ports, as we have mentioned last time. We talked about two types of these multiplexing, demultiplexing for the case of datagram sockets and for server sockets. We talked about the datagram socket being the socket is identified by only the destination port number. That's all. Okay. Versus the server socket, we mentioned that it's identified by 4 different parameters: the source and destination port and the source and destination address. If any of these values change, then the socket, we have to have a separate socket for this. Then we switched to talk about reliable data transfer, and we talked gradually, assuming that the channel is perfect and it does not have any sources of errors or packet loss or anything, and we started to design how to provide reliable data transfer given this assumption. And then we relaxed the assumption bit by bit. So we said that, okay, so the channel does not have packet loss, but it can introduce some errors, and it can introduce the error to the packet, or it can introduce the error to the acknowledgement, or both. Okay, then we started to talk about how to remove the negative acknowledgement to try to make the technique a little bit more efficient. So finally, we talked about stop and wait, which is the first, although trivial, but it's the first practical technique that supports the transfer of only one packet. Okay, so you have to wait for an acknowledgement for each packet before you send another packet. Okay, then we started a little bit of analysis for stop and wait. So we started to analyze with respect to the channel utilization or the session utilization. So we calculated the transmission time, and we calculated the round trip time, and then we calculated the utilization. So that motivated us to start to visualize the fact that on one session we have only one packet going back and or forth, okay, versus if we have a scenario like this, which is what we call data pipelined transport layer protocol. For pipeline transport layer protocols, we can send these packets without expecting any acknowledgement to come from the other side. So we can send up to n number of packets or n number of segments before we can expect any acknowledgement. Okay? And of course, as we can imagine, with that assumption, we can multiply the channel utilization in orders of magnitude. So basically, the number of segments here can be multiplied by the channel utilization for the stop and wait, and this way we can enhance the channel utilization as we have analyzed in this particular scenario. So the channel utilization is still, it's the one transmission time plus the round trip time, but this time we can multiply by the number of packets. So in that case, we can triple the channel utilization or quadruple the channel utilization by increasing the number of packets here. Okay, so now when we think about pipelining these segments, there are two possible ways of thinking about that. That's what we need to talk about today. The difference between go back end and selective repeat. Okay, so that's what we need to talk about and analyze today. And then we will talk about TCP as a protocol, because so far we're talking about techniques. Okay, so how is TCP designed? Does it use any of these techniques? Does it use a mix of them? What does it use exactly. So pipeline protocols are divided into two types, the go back N and the selective repeats. The biggest difference between the two is simply based on the assumption that here reception مش عارف ليه بتاع ده صورة. سلام عليكم. وازاي الواحد بيعمل بيخلي اللاين اصغر مش عارف. مش ما علينا. Reception is ordered. Okay. So the most important thing here is that reception at the receiver side, okay, it has to be received in order. Okay. So we have to receive a specific packet, and we cannot accept any packet after this before receiving that particular packet. So packet 2 has to be received before packet 3. Okay? And packet 3 has to be received before packet 4. So in other words, we can simply say that we expect one packet at any point of time to come. If that packet does not come, I will not accept anything. That assumption simplifies the complexity of the receiver. It simplifies the complexity at the receiver significantly. Okay, as we will see. The problem is that go back N has a certain disadvantage that we will talk about, okay, which motivated the introduction of what we call selective repeat. So if we talk about selective repeat, now we will relax this assumption. So here, reception is, in general, is a unordered. So in that case, if I'm waiting at segment 2, okay, so I happen to logically wait for segment 2, but I receive segment 3, okay, will I accept it? Yes, for selective repeat I will accept it, okay. So that's the main assumption, but we will see the implication of this in terms of the design of these techniques. The complexity of the reception has increased significantly for the case of selective repeat, and we will see how and why this happened. ماشي؟ طيب, so for go back N, so we go back to a go back N where the reception is in order. The sender can have up to N unacknowledged packets, and what that means is when I send the first segment, this is stop and wait. For stop and wait, I will not send any second segment until I receive an acknowledgement. That's what we said, right? So here, no, I can send all the packets back to back. I can send up to N packets back to back without having to wait for acknowledgement. Okay? So assuming that, that's why it's called pipeline. Assume that while I'm sending packet 2 or packet 3, I will receive the acknowledgement for packet 1. So I will keep going. I always keep going, and that increases the channel utilization, as we will see. Okay, so that's very nice. So I don't have to send one packet and wait for acknowledgement. I can using this technique, I can actually send all the time and receive acknowledgement. And whenever I receive acknowledgement, I will keep sending. As long as the receiver is coping with what I'm sending, I will keep sending. In which case, I can reach high level of channel utilization, which is nice. Okay, so that's the happy path. But what happens if if there is any acknowledgement that was lost? Okay, will that cause any problem? In fact, if one acknowledgement is lost, it may not affect the transmission by any means. So here, the receiver only sends cumulative acknowledgement, which means that if I'm sending segment 1, I will send segment 2, I would send segment 3. I'm supposed to receive acknowledgement 1, acknowledgement 2, acknowledgement 3. I did not receive acknowledgement 1 and acknowledgement 2. I received acknowledgement 3. What does that mean? Yeah, so I keep going. That's nice, right? This is nice. Which means that acknowledgement is actually cumulative. Yani one acknowledgement supersedes all the previous ones. Oh, that's nice. This is really good. Okay, so even if some acknowledgements are lost, I will not be affected by any means. That's great. That's based on the, that's actually very much related to this assumption. This is very much related to this assumption because I'm assuming that the receiver is always receiving all the packets in order. So if the receiver sends me acknowledgement 3, this will not happen except if the receiver received successfully packet 2 and packet 1, صح? So we can make the acknowledgements cumulative because of the fact that we have this assumption that reception is always in order. واضح كده? So far so good. So what is the problem now? So it seems يعني go back in is really nice. Okay? So sender has a timer. That's another piece of good news. So sender has a timer. Okay? So the timer is one timer per all the end packets that I'm trying to send. Okay? Why? Again, because the reception is always in order. So the timeout is used for what? Is used to make sure that I will receive at least one acknowledgement, okay, before the timer fires up. Okay? So again, because of the fact that the acknowledgement is cumulative, once I receive one acknowledgement, I have to reset the timer and restart it. So I only need one timer at a time. Okay? That's really good. Okay, so it seems that with go back N, I was able to increase channel utilization. I made the acknowledgements cumulative, which is nice. Even if some acknowledgements are lost, I will not be affected. And still, even though I can send in unacknowledged packets, but I'm using only one timer. So complexity-wise, it's nice. This whole technique is based again on this assumption. This assumption is the most important thing. Reception is always in order. Okay? What is the problem? We'll talk about the problem and the disadvantage for go back N. But we have to talk about it visually. Okay? So basically if we're saying that I sent segment 1, send segment 2, send segment 3, send segment 4, okay? So at some point, one of these segments is not reaching the receiver. So the receiver received segment number 1, segment number 2, and then segment number 4, okay? So now we have two questions. First, will I accept segment number 4? No, has to be in order, okay? 2, what acknowledgement should I send? Should I send acknowledgement for packet 2 or packet 3 or packet 4? Definitely not packet 4. In fact, I should send the acknowledgement for the last successfully received segment, which is packet 2. Okay? Type. But the problem is, before this acknowledgement reaches to the sender, if it happens that the timeout expires, okay? The timeout expires, this indicates to me that I did not receive the acknowledgement on time. What do I have to do here, Ba? Should I retransmit segment 1 or 2 or 3 or 4? Which one should I retransmit? This is the main problem, Ba. This is the main problem. I have to send all of them. because I don't know which one was lost. This is the major problem in go back N. This is the main disadvantage. If ever the timeout expires, I don't know which one was lost, so I have to retransmit all the window again. This is the main motivation behind selective repeat. Selective repeat tries to fix that. Okay? So concept for that. You will send an acknowledgement, but the problem is, if ever go back and the timeout expires, I don't know which of these packets caused that problem in any way, or which acknowledgement that was delayed that caused the timeout to fire up. So we don't know. So we have to retransmit everything. Right.
And the acknowledgement of 2 has been delayed, so that's why we need to resend the whole thing.
Yes.
But I'm just thinking, if acknowledgement 1 didn't receive...
خلاص, if acknowledgement 1, yes. If acknowledgement 1 was received, we will see now. We use a window technique, so we slide the window. So now we are at packet 2. So we start retransmitting from packet 2, not packet 1. خلاص. Any segment that has been acknowledged, خلاص بتخرج برا اللعبة خلاص. Okay? So we'll see that visually. So the whole motivation behind selective repeat is that big disadvantage that if ever a timeout expires, I will have to retransmit everything. So can I avoid this? So maybe the acknowledgement was delayed, but all the packets arrived, and there's only one packet that was not received by the receiver. Okay, so in that case, we can accept packets even if they are out of order. Okay, and if a packet, if the timer fires up, we send only one packet, which is the packet assigned to that timer. So every packet has a timer in that case. Okay. So again, this is in a nutshell. I'm not expecting you to understand everything 100% because we have to talk about this in details next. But here we say that the receiver acknowledgement is in that case not cumulative, it's individual. So acknowledgement for packet 4, okay, may be received by the sender, okay, before the acknowledgement for packet 3. Okay, so that may happen, and each acknowledgement indicates that this particular segment has been received successfully. And sender بقى هنا maintains a timer for each segment, not one timer for all the n segments. Okay, طبعا هنا the complexity is much more. So imagine هنا the timers are O of n. Okay, and the acknowledgements also are individual. So that increases the complexity of the receiver. But here the main thing is that we are trying to avoid the idea of retransmitting all the n packets. And we'll see another level of complexity in the receiver design again in a bit. Okay, so for go back n, the mechanism that we use to allow the sender to send in packets is what we call the window technique. Okay, so the window is a virtual box. So here we have the application, okay, and here we have the network layer, and this is the transport layer. So from the application we receive the information, whether it's like a web page or something, and then we divide it into segments, and then these segments will be sorted from 0 all the way to whatever, like 3,000, 4,000 segments. Okay, and then in the transport layer, the transport layer protocol will maintain a virtual box. We call it a window. Okay? So this window will divide the segments in the buffer into 4 different regions. 4 different regions, okay? 2 are inside the window and 2 are outside the window. So here, these green ones are segments that have been sent successfully. The acknowledgement for them has been received successfully, okay? Which means they are done. I'm done with them, خلاص. I don't have to do anything else. Everything is done. ماشي? That's why they are outside the window, because خلاص يعني I'm done with them. Okay? طيب, inside the window I have two parts of the segments. The yellow ones are the segments that I sent, okay, but I did not receive the acknowledgement for them yet. But I don't have to wait, right? I can keep sending. صح كده? So these blue ones are the segments that are available inside the window, which means I can send, but I did not send yet, and therefore, of course, I did not receive any acknowledgement. صح كده? Okay? But I can send, I don't have to wait. I can send, right? And these are the ones outside the window which are not sent, not received acknowledgement for. I cannot send at this point because they are outside the window. فهمنا الفرق بين ال 4 regions? Okay? Any question regarding this? Okay, so the window itself is defined by 3 parameters. Okay, so we control this window using 3 parameters. Okay, there is a pointer that points at the first location of the window, which is the base. The base always points to the beginning of the window, and we'll see why. Basically, if the timer fires up, I have to go from the beginning of the window and retransmit. So I have to have a pointer at the beginning. ماشي? And there is the next sequence number. Next sequence number is the segment that I will send next. Okay? In between those 2 pointers are all the segments that have been sent, but I did not receive the acknowledgement for. Of course, the 3rd parameter is the window size. It's called go back n. So n is predefined parameter. Whether this parameter is like, I can send like 10 segments before I have to wait for acknowledgement, or whatever. Okay? So any question regarding that? Type.
Who gives the number, the sequence number to the sequence?
Who gives the sequence number? Who gives the sequence number? The protocol defines the sequence number, but the important thing, since you've talked about that, how many sequence numbers I need? أتفكر إحنا for stop and wait. For stop and wait, we can send only one segment, and we have to receive acknowledgement before sending another segment. How many sequences did we need in that case? 2, 0 and 1. صح. So how many sequence numbers we need here? Eh? Bravo عليك. Yes, n plus 1. n plus 1. Right. Why is this bad? Why is this? As we said last time, because when if we have a sender and we have a receiver, okay, and then the sender sent the segment, okay, the receiver sent the acknowledgement, and the acknowledgement was lost, okay, so the sender sent the packet again. So here the receiver needs to distinguish between whether the incoming segment is a new segment or it's the same segment. So I have to have a 0 and 1. So we have 2 states, right? For go back n, I can send any segment within the window. Okay? So that's why I have to have n plus 1. Okay? And why 1 بقى? This is because of the fact that if we look at the receiver side, بقى, how does this window look like at the receiver? In fact, at the receiver side, the buffer looks like this. The segments are coming in, okay? So these are the segments that have been received successfully. So you will see here, I have only one pointer needed at the receiver, which points to the segment that I did not receive yet. Okay? طيب, as we said, assume that this segment has a sequence of I. Can I receive a sequence number I plus 1? No, because in go back n, the reception is always a order. So if we receive a packet with an index or with a sequence number I plus 1, I will not accept it. I will not insert it in the buffer asli. Okay? So, in other words, what is the window size at the receiver? It's 1.
One packet.
The window size at the receiver is 1. Because I'm always expecting one segment to come. That's it. So the window size at the receiver is 1. The window size at the sender is n. Okay? What is the sequence number? It's the window size at the sender plus the window size at the receiver. Basically. Because the worst case scenario is that you have the two windows, the sender at the sender and the window at the receiver are next to each other. So you need as many sequence numbers as the two windows concatenated. And we will see that for the selective repeat, we have a window at the sender, we have a window at the receiver, and the sequence number has to be the summation of both. Again, if you didn't get that, we will explain it again and again. Okay, so now we know that we have a window at the sender for go back n. We can characterize this window using 3 parameters: the base, the next sequence number, and the window size. And for the receiver side, we only need just one pointer to point at the location that I'm expecting the segment to arrive. ماشي كده؟ طيب, so here, if I receive an acknowledgement for this segment, this means that all these segments are implicitly acknowledged. صح? So in that case, I can slide the window all the way to here. Okay? So that's the sender. This is the finite state machine for the sender. And we have actually merged all the states into one. And that's one possible design. It's not the best. In my opinion, it's not the best. I would split it at least to 2 states, just to see the value of finite state machine. But here in the book, they use only one state, and they put all the events as events and actions and so on. That's fine. So we see here, if we have like phi, this means this is the initialization. So we initialize. What do we need to initialize? We need to initialize the base, which is the beginning of the window, and we need to initialize the next sequence number, which at the beginning, of course, it has to point to the same location of the base. Okay? And طبعا n is fixed. We have here four different branches that we need to talk about. In order to make this easier for you, you can imagine that we have this is the transport layer protocol, okay? This is the protocol, and in order to make this easier for you, to visualize it easy, you assume that what events that might happen. We have 3 types of events here, 3 types of events. We have an event for request to send that comes from the application layer, right? So we have request to send, okay? And we have an event that comes from the network layer for the ايه؟ for what kind of packet I receive اللي هو ايه اسمه ايه؟ acknowledgement received, okay? So acknowledgement received, okay? And we have an event, internal event بقى اللي هو بنسميه ايه؟ التايم اوت. Okay? So these are the three events. So the sender has these three events. Okay? So we need to make sure that all these three events with all the associated variations are addressed. So for example here, we see here مثلا ماشي. So we see here مثلا here this is the initialization. This is for receiving packets from the network layer اللي هي ان احنا we are expecting it to acknowledgement to come. But this acknowledgement might be corrupted or not corrupted. If it's corrupted, for go back and if it's corrupted, what does that mean? This means that I received an acknowledgement and it's corrupted. Okay? In stop and wait, if you go back for stop and wait, okay, you will see that I've done something here. But here I'm not doing anything. Why? Because for stop and wait, I send one packet at a time, صح? If I received an acknowledgement and it's corrupted, okay, what is the possibility? The possibility is this is the acknowledgement for the packet that I sent, but it was corrupted, okay? So in that case, I may be proactive and retransmit the packet, even though the acknowledgement was corrupted, because it's one packet. But here I cannot do that. I cannot do that because I don't know whether this acknowledgement is for segment 1, segment 2, segment 3. What should I do? And I don't have to send to retransmit the entire network every time I have a corrupted acknowledgement. It's not efficient to do that. Okay? So that's why if you see something for stop and wait, if you see something here, that's why. Because for stop and wait, it's not a big overhead to retransmit because it's only one packet. But here, I abstain from retransmitting the entire window every time I have a corrupted acknowledgement. We see the difference? ماشي? طيب, if the packet is not corrupted, then the acknowledgement, we said that the acknowledgement is cumulative, okay? And the acknowledgement causes the window to slide. Okay? Because everything is in order, right? So if you go by here, you see that what I did is that the base, if I change the base, this means I'm technically sliding the window. So the base becomes the get acknowledgement number plus 1. Okay? Because this means
the lower event occurs.
when the lower event, yes, this is for the lower event. Lower event معناها acknowledgement received. Okay? If this acknowledgement is not corrupted, which means it's legitimate, okay, so what I need to do is to use the acknowledgement number to slide the window. Because again, everything is ordered. ماشي? And in that case, there are two possibilities. One is that I may slide the window and then I see the next sequence number is the base. Okay? So if that happens, then I will stop the timer. Why? Because this means that everything is in the window has not been sent. يعني بشتغل على ماء بيضاء يعني زي ما بيقولوا كده يعني the window is becoming empty and it's clean and nothing is sent yet. So when I stop the timer, when I go here, to start sending the first segment, I will start the timer. So this stop معناها okay, so I'll stop the timer. So when I come here, I will start the timer clean. Because this means that every segment in the window is waiting to be sent. Okay? But otherwise, ده معناها ايه؟ ان some packets inside the window have been sent. Okay? So that's some packets are already sent, but the acknowledgement have not been received. So this means a restart timer. Actually, this is more accurate. It's not start معناها ايه؟ Stop and start. معناها يعني the timer will start from zero or will start from the highest level because it's a countdown timer. يعني assume مثلا the time is 2 seconds ولا 2 milliseconds. Okay? So stop the timer معناها خلاص the timer is stopped. So when I come here I will start معناها I will have 2 milliseconds fresh. This start timer معناها ايه؟ The timer may be مثلا at 1.5 millisecond, so I will start from 2 millisecond again. Because some segments in the window have been sent and not acknowledged. Okay, so this is the slight difference. Yeah. Okay, طيب. This is the event that comes from the application layer, اللي هو RDT send. This is the application layer transmission. So in that case, I will see. So if I have a segment that is coming in, first I have to make sure that it's within the window, right? Because if it's within the window, I can send it. If it's not within the window, I will leave it, but I cannot send it. So if the next sequence number is at the base plus n, معناها it's within the window, then and only then I can make the packet. Make packet معناها إن أنا I can بقى this is the data part of the packet. I will add the header to it, and the header بقى contains the checksum, the sequence number, and so on. Okay, and then I will send the packet. When I send the packet, I will start the timer. That's why I stopped it here. ماشي? If it's not within the window, I will refuse it. I cannot accept it at this point. أيوة.
In this case, sequence numbers not within the window, then it's like have the case of all packets have been sent, but no acknowledgement have been
delayed ولا حاجة.
Yeah.
Okay, that's fine. Yeah, this is the case. Yeah, this is the case that you're talking about. So I sent مثلا all the segments in the window. All of them have been sent, but I did not receive any acknowledgement. And it may happen because of the fact that the receiver is very slow to send the acknowledgements, or maybe the backward channel is very erroneous. Okay, and all the acknowledgement that gets sent from the receiver to the sender, they get lost on the way for some reason. Okay, so it may happen that I sent all the segments in the window, and then I did not receive any acknowledgement. Because of the fact that I did not receive any acknowledgement, I cannot slide the window. Okay, so the incoming segment, when it comes from the application layer, it finds that the window is full. So I cannot send it. So in that case, I have to refuse it. Okay? This is the disadvantage here. This is the disadvantage that we talked about. So whenever I have a timeout, okay, I cannot tell which packet to retransmit. I have to retransmit everything. Okay, so this is the main motivation behind the selective repeat. So I have to send from the base all the way to the sequence number -1, I have to send all of them. Because the next sequence number always points to the segment that will be sent. Okay, so I have to send everything before it. واضح كده؟ anything that's not clear here?
Stop timer. Just only in one case the timer will going to stop, but
Right. This corresponds to, again, this corresponds to this case. انا مش عارف ازاي اخليه. ايوه تقريبا هو دي. اوكي تقريبا هي دي. This corresponds to this case.
but if the timer will start the timer again, it will be from the beginning because it's just only in one case. If the base equal the
If the base equal to the next sequence number, this means I have
the start time equals 0 means it's from the beginning. So
equal 0. أيوة. This means from the beginning. Okay.
yeah, because
Stop timer معناها خلاص the timer is not running anymore.
but
Okay.
for start
Because I'm
time-
not sending any packet. I did not send any packet. Because the متلخبط بس البتاع ده مش عارف انا. فين الدوت دي؟ دي برافو عليك. اوكي. لا برضه. صح كده. صح. طب دي البي. خلاص انت ده ايه ده؟ ده راح فين؟
الرولر حضرتك فتحتها صح؟
فين الرول بقى؟ دي خلاص مش عايز. كويس. Okay. So this is the base. Okay. And this is the next sequence number. كويس كده؟ كويس. ده معناها ان everything in between from here to here, these segments have been sent, okay, but not acknowledged. صح كده؟ But this segment was not sent yet. صح كده؟ تمام. Gale sender received acknowledged. Okay? And this segment is I. Okay? And this acknowledgement has a sequence number of I. This means that this segment have been received by the receiver successfully. صح كده؟
for starter time the
يبقى لا خلينا بس ما لناش دعوه بالتايم. التايم شغال. هو التايمر دلوقتي شغال. يعني التايمر is counting down. Okay? But did not expire yet. Because احنا here we're not talking about this event. Here we're talking about an event. Here we're talking about an event where we received the acknowledgement, okay, and this acknowledgement has a certain sequence number, right? So this sequence number, the acknowledgement was received, not corrupted, everything's fine. So what I will do is that I will set the base to this I plus 1, okay, which means that the base will point at here. صح كده؟ صح؟ يبقى the window will start from here all the way. ما شاء الله.
every time start from the beginning.
Yeah, لا. Here بقى the base, when I slit the window, the base happened to be at the same location as the next sequence number. What does this indicate? This indicates that all the segments in the window have not been sent yet. صح? So there's no timer to fire here. The timer gets started only when I send at least one segment from the window. Okay? So if the base happens to point to the same location of the next sequence number, this means that everything inside the window has not been sent yet. So that's why I stop the timer, because I will start it again automatically when I start to send the first segment. واضح كده بقى؟ Clear? Okay. Otherwise, if the base at any point here, this means that the window has some segments that already sent but not acknowledged. Okay? So in that case, I will restart the timer. Not بقى I will restart لأن the timer starts whenever I have at least one segment inside the window sent and waiting to be acknowledged. صح كده؟ So if the base is not equal to the next sequence number, this means that some segments in between have been sent already and not acknowledged. So in that case, I will restart the time, not stop. We'll start again from 2 milliseconds and we'll count down. واضح كده؟ The next sequence, no. The next sequence number will keep incrementing على طول. Now we have you mean like you mean because احنا ماشي, we'll talk about this next. احنا what is the minimum number of sequences? Here احنا we assume that a sequence ماشي إلى ما شاء الله. يعني مثلا assume that n is 5. What is the minimum number of sequences? 6. So we start 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and so on. So whenever we say increment next sequence number, this means اللي هي ايه modulo 5 or modulo 6, modulo 6. So when it comes to after 5 is 0, after 5 is 0. So it's modulo 6 we say. ماشي? Any questions? I like the questions very much يعني, because it indicates to me that you are يعني following, and if you have any question don't hesitate يعني. اتفضل.
The value of the base is reassigned to.
Yeah, the value of the base. Whenever I receive an acknowledgement, the value of the base changes to indicate a sliding the window. It's technically معناها ايه? I slide the window. يعني معناها ايه slide the window? That all the n packets or the n segments in this window are I can send. The ultimate goal here is that by the time I finish sending the n segments, I will have received at least one acknowledgement, which means I will always keep sending, and that's the scenario that I'm looking for, because this means that the channel utilization is the maximum. I'm always using the channel to send. ماشي؟ يعني unlike مثلا اللي هو stop and wait. I send one packet and I wait بقى ما شاء الله لغاية ما يجي acknowledgement. Any questions? Any other questions? يا ريت اتفضلي. How do we? The window size. The window size. This is pretty. يعني it's set by the protocol. يعني حتى it's not in the standard, by the way. It's not in the standard. يعني the designer or the developer can set it to any number. It doesn't matter. بس طبعا هي ليها علاقة بالإيه؟ It is directly related to how much channel utilization you can set. بس هو we will see بقى how TCP deals with that, because TCP بقى when we talk about TCP, we will see that TCP does not use any of these techniques. It uses actually a mix of all of them. It uses a mix of all of them. So we will see that TCP بقى uses different n and it keeps incrementing n بطريقة معينة exponential. يعني هنشوف يعني مش we have to talk about that. طيب, the receiver for go back n, this is بقى the good news. The receiver is relatively simple. Relatively simple. لأن why? Because of the fact that the receiver assumes that I always receive segments in order. Okay? So that's why here you see that I expected sequence number. This expected sequence number is the only parameter I need to maintain at the receiver side. So the receiver, you see the buffer is like this. I have segments coming in, and this is the expected sequence number. All of these have been received, and this is the one I'm expecting. That's it. If I receive anything here, reject. This is that scenario. لا مش ده we'll talk about that. So when I receive anything outside the window, and the window here is just one, very simple, it's just one. Okay? So if the packet is received and it's not corrupted and it has the same sequence number that I'm expecting, that's the only scenario where I will extract the يعني extracts عكس make packet. Make packet adds a header to the data. Extract packet removes the header from the data, preparing the data to be sent to the upper layer, اللي هو application layer. So extract, deliver the data. Okay? طبعا the delivered data is always in order. We'll see بقى even for the selective repeat, sending the data to the application is always in order. Is always in order. Okay? حتى in the case of selective repeat. عشان برضو this is an indication to you, when do we call this deliver data? Deliver data معناها send the segment to the application layer. And we send it only if it's in order. Okay? So we'll see بقى for the case of selective repeat, when do we call this function? And then طبعا we send what kind of segment is this, or what kind of signal is this? This is the acknowledgement. So I put the expected sequence number in the acknowledgement and the checksum, and I send it. And then I increment. معناها I slide the window for the receiver. The window here is just one. ماشي؟ طيب the default بقى otherwise the default otherwise ان هو ايه بقى؟ I received a segment but it was corrupted. Okay? Or I received a segment not corrupted but the sequence number was not the expected sequence number. Okay? So that's a otherwise. Okay? In all other cases in all other cases, this is what do we do here بقى? We need to send some kind of negative acknowledgement, but we said that instead of sending negative acknowledgement, what do? We send positive acknowledgement of the last successfully received segment. ماشي؟ That's why ان احنا -1. So instead of sending negative acknowledgement to say that I received something in error, لا, we send اقول له بص انا I received up till here. تصرف انت بقى. Okay? Any questions? تمام. So this is the case of go back in and how it looks like from a time perspective. So when we send packet 0 and then packet 1, packet 2 was lost. Okay? So if I happen to have a timeout event at this point, I have to go back from packet 0, even though packet 0 arrived, packet 1 arrived. But I don't know. I did not receive any acknowledgement, and I don't know which packet was lost, and the timer expires. So I have to go from the beginning and retransmit. Here it happens that I received the acknowledgement for packet 0. So what will happen here? Slide window 1 position. صح كده؟ And then I received acknowledgement for packet 1. So again, slide window 1 position. نفس الشيء. Okay? Here بقى, this acknowledgement was lost. And this acknowledgement was lost. Okay? So at some point here I will time out. طبعا packet 0 and packet 1 I received the acknowledgement for, so I will start from packet 2, packet 3 and so on, and I will keep going. ماشي? So there's no overhead here because of the fact that I happen to receive the acknowledgement for packet 0 and packet 1. And packet 2 is the one that was lost. Okay? So there is no overhead here because I will start again from packet 2 and I will continue. Okay? But as we can see, the timeout calculation is very critical because if the timeout is premature and it's short, okay, so in that case I will fire the event of retransmission often, and every time I have a timeout I have to retransmit the entire window, which means I will have big overhead for no reason. That's why يعني TCP, we'll see بقى how TCP calculates the timeout. It's very, very critical. This is the most critical parameter أصلا. ماشي؟ طيب, so again, because of the fact that whenever a timeout expires, we have to retransmit the entire window, and it's a little bit inefficient. So the selective repeat tries to solve that by having individually acknowledged segments. ماشي? The sender, if in that case بقى, if a timeout expires, the sender will send only the segment that the timeout expires for. So in that case, the timeout has to have a sequence number, like the segments, like everything. Okay? So we can start how many timers at the same time, up to n. So we can have up to n timeout timers, okay, for every segment in the window. ماشي؟ طبعا maintaining n timers is يعني حتى يعني from a software perspective or حتى from a hardware perspective, it's an overhead. Of course, it's an added complexity. But this is the only way we can accommodate the fact that when a timeout happens, we don't have to retransmit the entire window. We retransmit only one segment. واضح؟ طيب. So here, the sender window is still in consecutive packets, and I can send all these packets without having to wait for acknowledgement. نفس الشيء. But here, the difference is not at the sender side. The difference is at the receiver side. So here, we see a situation which is very interesting. On the sender side, we have a very interesting situation. Some segments I sent and I did not receive the acknowledgement for. Some segments I sent and I received the acknowledgement for, but I cannot slide the window. So here, I cannot slide the window. Okay? Why? Because the first segment in the window was not acknowledged. ماشي؟ واضح كده؟ I cannot slide the window. If I slide the window دي معناها خلاص this segment I may never receive any acknowledgement for, and it may never arrive to the receiver, and I don't know, and I keep going. خلاص ده كده everything is corrupted يعني. I cannot do that. ماشي؟ When do I slide the window? At the sender side, when all the segments have been acknowledged correctly. Because of the fact that here acknowledgement is not cumulative. Okay? So I cannot slide the window. That's a very interesting situation that we did not have before in the case of go back in. So here I have three types of segments. Segments sent, not received the acknowledgement for. Segments sent and acknowledged. Segments not sent at all. And I have to maintain a state for each segment. يعني at any point of time, okay, I have to ask the segment, are you acknowledged or not? يعني لازم يكون في parameter, one flag maintained for each segment saying whether this segment have been acknowledged or not. Again, this parameter or this flag has not been used for the go back in case. I did not have to do that because I know that everything from the base pointer to the next sequence number, everything is by default sent but not acknowledged. صح؟ خلاص. I don't have to maintain a state for each segment. But here I have to. Because segments are mixed up. Some of them are sent and acknowledged. Some of them are sent and not acknowledged. Some of them are not sent at all. So I have to have a flag. واضح؟ I did not have to do that for go back in. نفس الشيء هنا. Here. This segment has not been received yet. This segment has been received. Okay? And I can accept it because the reception doesn't have to be in order. واضح? So here you have a window of n, here you have a window of n, and again to answer the question of the minimum number of sequence numbers, you imagine the worst case when these two windows are concatenated كده. So we need as many sequence number as this window plus this window. 2n يعني basically هنا يعني. ماشي؟
شوف يعني هنا الاكسبكتد مش رقم مهم قوي لان اي حاجه هتيجي بعدها ممكن تجيب العادي صح؟
Yes, but I have to maintain it. صح مظبوط كلامك مظبوط. بس here بقى similar to the fact that I can slide the sender window. هنا I can برضو slide the receiver window. And remember in the go back end I can slide the sender window more than one position at the same time, صح? I can do that because we said that acknowledgement is cumulative, صح? So we were able to slide the window 3-4 positions in one shot. We can do that. Here, we can also, interestingly speaking, we can slide the receiver window more than one location in one shot. And we'll see about how this will happen. ماشي? Any questions so far? لا دي يعني مفهوم ولا ما فيش questions يعني؟ مفهوم ما فيش questions يعني. Okay. Words. Here, this segment was not received. صح? This segment was received. And this segment was received. This segment was not received, and this segment was received. Okay? So now I received a retransmitted segment, and it happened to have this sequence number. What does this tell me? Okay, so this is the start of the receiver window, right? So this means I can slide the receiver window, at least one position. And then I check the state of the next segment. If it's received successfully, then I increment. I go to the next one. Received successfully, I increment. So whenever I increment, I deliver to the application. Right? Because all of these are in order. Okay? And then I come here. Is this received? No. So I stop here. Well, that's why we deliver to the application layer only when we slide. And we slide one by one. Okay? And we slide whenever we receive the segment that fills the gap. So we can slide the window and send up. Slide the window, send up. Slide the window, send up, and so on. So we can slide more than one position in one shot. Okay? Anything that's not clear? طيب. So if the next available sequence number in the window, then send that. This is the logic يعني, that we talked about. Here, the timeout, as we can see by here in the timeout, I have to have an index of the timeout. So I can have up to n, capital N, timers fired at the same time. So when any timer expires, it has to tell me what is the number of that timer. Okay? Because that's what I use to send only this packet. Only this packet. ماشي? So the acknowledgement, again, the acknowledgement is not cumulative in that case, and the acknowledgement indicates that this only packet has been received successfully. But that doesn't mean that anything before it was received successfully. So it's not cumulative. So if packet n is within the window, we send the acknowledgement, which indicates the exact same packet that has been received successfully, and it may be out of order. However, the delivery to the application must be in order. Must be in order. Okay? So regardless of the reception is allowed to be in order or out of order, but the delivery to the application layer has to be in order. So when do we deliver data to the application? We deliver data to the application only when we slide the receiver window. Because we slide the receiver window when we are sure that everything in the window is received in order. Okay? So ماشي كده؟ طيب. So here بقى ايه the time sequence. So here we have more than the minimum sequence number. We have four. The n is 4. So we have 4 here and 4 here. And alhamdulillah, we have more than 8. We have like 10 sequence numbers, so that's fine. But the minimum is 8. So here we don't have a problem. So if we send packet 0, right? The slide here happens if we receive the acknowledgement for packet 0. So here, when we send packet 0 here was received. So it fills a gap, and it's in order, so we slide. We slide the window, okay? And then we receive packet 1, so we slide. So the receiver slides whenever I receive any packet in order. خلاص, we slide. We keep sliding, عادي. Okay? This packet was lost, and I sent packet 4. Until now, I cannot slide anything on the sender side because sliding on the sender side is activated by receiving the acknowledgement. صح? So here, I receive packet 3. So packet 3 is within the window. So I will accept it. I will put it here. I will accept it. Okay? But I cannot slide. صح? When do I slide? When I receive segment 2. Segment 2 is not received yet. So segment 3 can be accepted, but I cannot slide. ماشي كده؟ طيب. Here, acknowledgement for packet 0 was received, so I will slide. Because packet 0 is in order, so I can slide. Okay? And then I receive the acknowledgement for packet 1, I can slide. Because it's in order. I can slide, no problem. Okay? طيب. Whenever I slide, معناها ان anything here can be sent, so I will keep sending. I can send packet 4 and I can send packet 5. ماشي? Because packet 4 and packet 5, they happen to be inside the window. So I can send 4 and 5, no problem. Okay? And remember here, 4 and 5, whenever I receive them, I will accept them. Packet 4 and packet 5 are accepted at the receiver side. But I cannot slide the receiver window because this one was not received. فهمنا ليه؟ يبقى احنا at the receiver side, yes, the packets are accepted, but I cannot slide. Because there happens to be a segment that was not received yet. So this whole thing will be activated by the timer that's assigned to this segment, segment 2. Only when this timer fires up, okay, I will retransmit segment 2. When I retransmit segment 2, you see here, the window has slid 3 positions all at the same time. واضح? Because segment 2 happened to fill a gap. And already 3 have been received, 4 have been received, 5 have been received. So, okay, so I can slide all of these. But in order for me to do that, I have to maintain again a flag, as we said. I have to maintain a flag for each sequence at the sender and at the receiver, which I did not have to do before. واضح كده؟ لا طبعا. لا يعني assume that here I send packet 6. لا خلاص. I cannot. لا خلاص. I cannot. Because this is outside the window.
From the sender side, I sent packet 0 and packet acknowledgement for packet 0 was received.
تمام.
Then this diagram is showing that I can send sequentially
Yes,
packet
oh,
1
yeah.
and I can even send packet 4.
Yes, because
So
when I
each one goes
because when I slid the window one position, now 4 has become inside the window, so I can send it.
So I have to send 1 first and then 4, or I can
لا
send
لا
either of them?
لا لا ما هو أنا I will keep sending until the timer for packet 1 fires up. If the timer for segment 1 was fired before I received the acknowledgement, I will retransmit packet 1. But it happened that the acknowledgement for packet 1 arrived before the timer of segment 1 fires up. ولا مش واضحة؟ يعني again هنا the acknowledgement for packet 0 arrived. صح؟
السيكونس
And
اللي انا همشي عليه كسندر هيبقى عامل ازاي؟
هو السيكونس اللي انا بمشي عليه كسندر انا اي كيب انكريمنتنج
يعني
لغايه حاجه من اتنين، يا اما يجي لي اكنولجمنت ده هيخرجني بره النورمال سيكونس بتاعي ان انا اي كيب سندنج، او ان التايم اوت fires up. If the timeout fires up, then I have to go back to checking what is the sequence number inside that timer, and I retransmit this segment only. So when I sent packet 0, okay, I received the acknowledgement for packet 0 before its timer fires up. طيب خلاص. Okay. When I receive that acknowledgement, I can slide the window. When I slid the window, segment 4 has become inside the window, so I can send segment 4. Okay? طيب هتقول لي بقى طب انت ليه ما رجعتش تاني لباكيت 1 وريترانسميت؟ هو I don't have to do that until its timer fires up. Otherwise I will keep going. ماشي؟ So I always move forward until the timer tells me otherwise. ماشي كده؟ So the timeout for segment 2 forces the sender to retransmit, which arrives here and causes by all this sliding for the window happens 3 or 4 positions at one shot. اتفضل. لا it doesn't have that doesn't say that. That doesn't say that لأن احنا قلنا كل sender أو receiver they have a mechanism for when to slide. Okay? So just the fact that I slid the window, that doesn't mean that these packets were acknowledged and the receiver received the acknowledgement for them. Who said that? Okay? So sliding these windows, while I'm sliding the window, by the way, I keep sending the acknowledgement back to the sender. But I don't have to make sure that the acknowledgement has arrived to the sender. I don't have to do that. Because if it ever happens that this acknowledgement was lost and the sender decided to send these packets again, I will reject them because outside the window, خلاص يعني. So the sender has a mechanism to slide, which is triggered by receiving acknowledgement. The receiver has a mechanism to slide whenever it receives segments in order. That's it. ماشي؟ طيب هو بقى هنا بقى to answer the question of what is the minimum sequence numbers. What is the minimum sequence numbers? In order to allow you to imagine that scenario, we have to imagine a scenario where we send all the packets in the window, okay, and the backward channel happens to be completely erroneous. Because this is the extreme scenario that will get the two windows to concatenate مع بعض. The sender window and the receiver window to concatenate مع بعض. Because I keep sending, whenever I send, the receiver keeps sliding, but the sender cannot slide. صح? So we will have the deadlock that the two windows, okay, they are concatenated to each other. Okay, so all the sequences inside these two windows, it has to be unique. So what happens if they are not unique? What happens if they are not unique? So this scenario here talks about the fact that the packet 0 was sent, the acknowledgement is lost. Packet 1 was sent, packet 2 was sent, acknowledgement is lost. If the window size is 3 and I have 4 sequence numbers, right? So here I'm expecting only one packet, like packet 3, and here I cannot send packet 3, صح? Because I did not receive any acknowledgement, so the situation will get stuck until the timer fires up. So I will keep going 0, 1, 2, والreceiver يفضل يبعت لي acknowledgement, and this acknowledgement will get lost, so we'll keep in that position forever, and there's no problem. ما عنديش مشكلة. But it will work as designed. This is the most important thing. So even if the backward channel is completely erroneous, it will work as designed. I will send the first 3 packets and then we'll get stuck. خلاص, it's fine. The channel is erroneous. هعمل لك ايه؟ ماشي؟ So here بقى we'll see بقى the situation that we have the 3. Yeah, so here okay, so we have 0, 1, 2, 0, 1, 2, okay, and yeah, so the acknowledgement, yeah, so this is not an error. This will not be an error. This also will not be an error. Yeah, so timeout expires 0, 1, 2. Yeah, so where is so this? Aha, okay. Yeah, so this is the one in error because of the fact that we're talking about selective repeat. So I got confused with the fact that here we're talking about go back in, but here the number of sequences are less than the two window concatenated, right? Because here we have 0, 1, 2, 3, right? So we have 4 sequences. بينما هنا we have the window here is 3 and the window here is 3. So together they are 6, right? So the problem here is that when the receiver here slides and it stops at 3, right? And here I send 0, 1, 2, okay? I cannot send 3 because of the fact that the acknowledgement was not received. So whenever I retransmit, I will retransmit segment A 0, okay? Type. What will the receiver do for this segment? Eh? It will accept it here because it's inside the window. Okay? Type. Is this correct? Why?
A different packet.
Just the fact that they have the same sequence number, it doesn't mean that this packet is similar to this packet. خد بالك. The content is different. Just the fact that they happen to have the same sequence number, that doesn't mean that the content is the same. These segments are different. They have different content. But here the receiver will erroneously accept segment 0 and will put it here in the buffer. This will corrupt the whole thing. And if ever I receive packet 3, I will send packet 3 and then packet 0 and I will send it up to the application layer. Application layer خلاص كده بالسلامة. كده خلاص كده الابلكيشن لاير هيشتغل حلاوه. ف this will not work. Why? Because of the fact that here we're talking about selective repeat, and we have 3 segments here and 3 segments here. So the minimum number of sequence numbers has to be at least 6. So I have to have 0, 1, 2, 3, 4. ماشي؟ So I have to have at least 0, 1, 2, 3, 4, 5 كمان. اللي هم 6 يعني. 6 sequences. So if I have 4 and 5 هتبقى دي ايه؟ 4 and this is 5. صح؟ So if I try to send packet 0, packet 0 will be accepted in that case? No, because it's not inside the window. Okay, but this will create the error. ماشي؟ طبعا of course this will work as designed, but that doesn't mean that this will work يعني this will work correctly because of the fact that the acknowledgement was received. So it may happen that you may have less than the 6 sequence numbers if the acknowledgement are received. It may work, ماشي? But that doesn't mean that it's a correct design. Because design is always based on the worst case scenario. Always. ماشي؟ طيب احنا we'll stop here and we'll stop here. Okay. As we have mentioned before, طبعا TCP is connection oriented. We talked about connection oriented. فاحنا we need to very quickly. طبعا I know that you are familiar with this. We need to study the segment structure for TCP. I assume that you are already familiar with this. Maybe we'll test you a little bit, بس احنا we're supposed to go fast. And then the most important thing is to how to talk about flow control and later on congestion control. This is the most important thing يعني for TCP, which probably we can cover next time. طبعا TCP is point to point, and what that means point to point غير device to device. Point to point here معناها one end application to one end application. ماشي؟ طب هو احنا do we have any other alternative? Yes, if we talk about multicast. So one end application can talk to multiple end applications all at the same time. Okay? So why TCP cannot be used for that scenario? TCP is used only for point to point. One application to one application, not multiple. Okay? So for the case of multicast, TCP does not work. And the main reason for this is the acknowledgement. Okay? Because TCP is not going to be efficient at all for point to multi-point communication. Why? Because if I send مثلا a packet, should I wait for the acknowledgement from one application, ولا all of them, ولا some of them, ولا UDP can work seamlessly because there's no acknowledgement, nothing. Okay, multiplexing and demultiplexing works fine for the case of point to multi-point. There's no problem because each end application on the other side will have its own port. مفيش مشكلة. The problem comes because of the fact that TCP is based mainly on acknowledgement. Okay, so cannot work for the case of point to multi-point. That's if you are wondering why it's point to point بالتحديد يعني, because it cannot work otherwise. ماشي؟ طيب, it works for the case of reliable. Of course, we support 100% of reliability. It's not even 50%, and that's one of the drawbacks of TCP. Because in some cases, perfectionism is not good. For certain, if we're talking مثلا about video streaming applications, perfectionism is not really good. ماشي? But TCP is one package, take it or leave it. ماشي? When we say in order byte stream معناها ايه؟ In order معناها we deliver to the application always in order. حتى لو بنتكلم على unordered reception. Unordered reception مش معناها خالص unordered delivered to the application, because that it's not يعني it's not possible. You have to deliver the segments to the application always in order. Okay. طيب ده اختلاف هنا بقى ان احنا بنقول بايت ستريم. بايت ستريم ده معناه ايه؟ ان احنا بقى بنقول احنا يعني the sequence number is the sequence of the byte, the first byte in the segment. يعني مثلا one segment here, let's say it starts from 0, okay, but it has a length of 1000 bytes, okay, and then the segment after this, so the sequence number of this segment is 0, right? So what is the sequence number of this segment? Is 1000, which is the start byte of that segment in the byte stream. ماشي؟ So the sequence number here, ده أول اختلاف أهو. TCP is different from all the other mechanisms that we've talked about. That it uses the byte stream, and it uses the sequence number as the sequence of the byte, of the start byte of this segment. واضح؟ طيب. So technically there is no message boundaries. So I can start from any location in the byte stream. Although of course we have a certain parameter here which is called maximum segment size. Okay? So we have a maximum segment size. So if I have a byte stream coming from the application, I can use the maximum segment size as the default length for every segment. And the maximum segment size here is 1000. But I will definitely end with مثلا some the last byte combination will have a length of, let's say, 110 مثلا bytes. خلاص, the byte sequence has finished. Okay? So the maximum segment size is from the name. This is the maximum length of any segment. But that doesn't mean that the segment has to have this length. It can be less than that. TCP is pipelined. Okay, pipeline هتقولي طب هو go back in ولا selective repeat? Actually, it's a mix of both. It's neither. Okay. In the standard, TCP itself is left to the developer to decide whether they need ordered reception or unordered reception. So in other words, if you want to use go back in, if you want to use selective repeat, if you want to use any mix between the two, you still comply with the standard. ماشي? That's why for TCP you have, as you can see here, you have list of RFCs. You have many implementations for TCP. You have several implementations for TCP that all of them comply with the standard. Okay? Okay, so we have end and receive buffer for, of course, and it's full duplex. Full duplex معناها ايه? Full duplex will mean that when we send a segment, we might actually set the acknowledgement for another segment that we have received before. يعني معنى ايه؟ And while I'm sending a segment, I can acknowledge another segment. Okay? So what we have been talking about is one direction. So the sender always sends the segment, and the receiver always sends the acknowledgement. صح? But in practice, the sender acts as the receiver, and the receiver acts as the sender, and they can send the segment or the acknowledgement at any point of time. Okay? So that's what we mean by full duplex. We have bidirectional communication. It's connection oriented, of course, as we have discussed before, that we have to establish a connection. So we need to establish a connection, and establishing the connection allows us to have certain guarantees, as well as allowing us to have some reliable data transfer. It supports flow control and congestion control, and we talked about the difference between the two. حد يقول لنا بقى الديفرنس between the two. حد فاكر؟ What is the difference between flow control and congestion control? اللي هو ايه؟
What was about not overwhelming the receiver?
أيوة.
Not about
انت اللي بتقولي صراحه مش عارف. لا صح برافو عليك. Yes. So yeah, flow control is to regulate the transmission rate to avoid overwhelming the ultimate receiver. This is flow control. Congestion control, again, to regulate the transmission rate, but this time is to avoid overwhelming the network or congesting the network. Okay? So we'll see some similarities, but they are significantly different. And we'll see how TCP بقى supports flow control and congestion control. Flow control is easy. Congestion control is always the most tricky part because, well, TCP does not have access to the network, but it needs to respond to the congestion that might happen in the network. So how can you respond to something that you do not see? Yani the network does not give you explicit congestion indications, but somehow you have to have a feel that the network is congested, and you need to respond to that. So yani we'd have to do that implicitly. So TCP does this. So this is the segment structure. It's supposed to be yani straightforward, and you might have, or you yani most likely have gone through this before. The most important part, of course, is these two fields, multiplexing and demultiplexing. This is a fundamental. Without this, you are not a transport layer protocol. ماشي? Type. For TCP, you have a sequence number, and here the sequence number is based on the byte stream, as we said before. Byte stream. Acknowledgement number does not have to exist in every single segment. So you set this acknowledgement number only if you want to acknowledge something while you are sending the signal. Okay? An acknowledgement number is actually correlated with this flag here, which we will talk about in a minute. So if this flag is 1, this means that this acknowledgement number is significant. It has a meaning. If this flag is 0, this means that this field is don't care. I don't have to worry about this. So it may have any garbage, I don't care. ماشي? And this acknowledgement is set whenever I want to acknowledge some segment that I have received before from the other side. Okay? طيب. This is the header length. A header length. And from the name, this is the length of the header, not the data. This is the length of the header. And the header starts from here all the way to here, because this is the application data. ماشي? So this indicates the length of this header. So first of all, why do we need to have a header length? Why do we need to have a header length?
For حضرتك قلت لما استقبل الباكت اعرف اشيل.
لا، ما هو صح مظبوط يعني، بس هو if the header has fixed size, do I have to have an explicit header length? No, because the header has fixed size. So I know when it starts and I know when it stops, because it's always fixed. So in that case, I don't need to have a header length. So you need to have an explicit header length only when the header size is variable. ماشي? So why do we need to have a header length? Because the header size might vary. And it actually varies from 20 bytes all the way to 60 bytes. So the TCP header, the minimum size is 20 bytes and the maximum size is 60 bytes. So what is between the 20 and 60? هو ده options fields. So this option fields makes the header length variable, and that's why we need to have this header size. Type. What is the purpose of the options fields? Surprisingly, nothing. طب هو محطوط ليه? Why do we need to have it? This is بقى يعني برضو this is a clear testimony that protocol developers are human beings. يعني they do mistakes, and this is actually a mistake. And not only this one, by the way. You have here this field. See, this is called a push data now. generally not used. Another one here. Where is it? Here, the urgent pointer. And here you have the urgent field. Generally not used. ماشي? So they use this flag and they put it in the standard and it was never used. Okay? Which increases the overhead. So this is an indication that standard developers sometimes they do things that are not necessary. They are not being used. Since they have been put in the standard, TCP is one of the predominant standards in transport layer. And yet you see this discrepancy in the protocol header. Okay? So options fields are not used in any way. This urgent pointer or urgent flag, not used. Urgent pointer, not used. Push, not used. طب هم بيستخدموا في ايه؟ This urgent flag indicates that part of this segment is urgent. Okay? Part of this segment is urgent. Urgent معناها you have to deal with it. ايه هو supposedly when I put a part of the segment urgent, supposedly بقى ان انا مثلا the network should deliver this segment very fast even if it's out of order and so on. Supposedly But again, this ends up never used. Because if that happens, this actually violates the isolation between the layers. So the network layer is totally isolated from the transport layer. And that's why these kind of flags are almost never used. This push معناها ايه؟ push معناها ان انا if this packet, if this segment was received at the receiver, okay, here, okay, even if it's out of order, I have to deliver this to the application even if it's out of order. Because we said that delivery to the application is always ordered, صح? Even if we're using selective repeat. That's a violation. And they made this violation in the standard, okay, to facilitate certain scenarios that have never existed in reality and therefore has never been used. So all of these are actually part of the standard, but they are never been used. ماشي? So the flags that are really important. The flags that are really important اللي هو this A stands for acknowledgement, reset, this is used, sync and fin. And these are used for handshaking, to establish the connection. To establish the TCP connection end to end, you use these flags. One bit. These are 6 bits. The 40 bytes are not used for anything. That's why in all TCP segments on the internet هتلاقي the length is by default 20 bytes, which means that this field is not needed أصلا, لأن if it's always 20 bytes, why do you need header length أصلا? You don't need that header length if it's always bytes. Because of the fact that they put this options field, they had to put an explicit header length field. These are all imperfections in the standard. IP على فكرة has the exact same notion So these are for connection establishment and tear down. ماشي? Anything that we did not cover here, I think we covered everything. Yeah, we covered everything. Anything that you that's not clear? Supposedly you have discussed this in network 1 كده فمفروض this is straightforward. But if you have any questions, we can focus on it. To jump into the important stuff for how to analyze the performance of TCP, particularly when it comes to flow control and congestion control. Okay. طيب some properties in the structure of the segment. If we talk about even stop and wait مثلا, and we have a letter, this is one letter which means that the data length inside the segment is only 1 byte. This is the simplest. So you have a sequence number which is 42. By the way, you don't have to start the sequence number from 0. There's no, in fact, it's recommended not to start from 0. Because it's a byte stream, you can start it from any number. It doesn't have to be 0. ماشي؟ طيب. So you have a sequence number 42, and at the same time, I'm sending an acknowledgement, okay, for byte 79 to host B. So we're no longer talking about sender and receiver here. Here we're talking about host A and host B, because both of them are senders and receiver. Sender and receiver at the same time, because we're talking about full duplex and bidirectional. واضح؟ طيب, what is the relationship between this sequence number and the acknowledgement number? Is there any relationship? Nothing. They are not related in any way. يعني the fact that I'm acknowledging byte 79 has nothing to do with the fact that I'm sending byte 42. So this is the sequence number from host A to host B. Acknowledgement is for something that was sent from host B to host A. But this has some correlation with this. And this has some correlation with this. تمام? So these are correlated بقى. ماشي? So when I send the sequence number 42, when the receiver, interestingly بقى خد بالك, when the receiver sends back, it sends an acknowledgement. Here the sequence number is 42. When I send an acknowledgement, I send acknowledgement a 43. Why? Because of the fact that I have a character here. Okay? So the start is byte 42, and the next byte will be 43. 43 is the byte that I'm expecting next. So the acknowledgement here refers to the byte that I'm expecting next. ماشي؟ معناها everything before I receive successfully, I'm expecting this byte next. ماشي؟ So that's what the acknowledgement for TCP indicates. Here we're talking about خد بالك TCP بقى, not mechanism. Here we're talking about specific standard. ماشي كده؟ So that's this is a simple مثلا telnet scenario where I'm sending characters back and forth. So how TCP works. طبعا في time out وفي كل حاجة نتكلم على الموضوع ده. So the most important question بقى for TCP is how to set the timeout value. Okay, because we said this is the most critical part. If the timeout is too short, we get so many timeout events unnecessary. صح? And we keep retransmitting, and that wastes the bandwidth of the channel by sending repeatedly, okay, segments multiple times unnecessarily. But if the timer is too long, then I will send everything in the window, and I will wait until the timeout happens. If the acknowledgement was delayed, so again I am wasting the bandwidth of the channel. So ideally, عامله كده ايه زي ايه بالظبط؟ زي ايه؟ Sometimes when you stand in the traffic light, okay, and you see nobody's crossing by, but you are waiting. يا عم خلاص. Okay, so you get frustrated. So in that case, the timeout of the traffic light was not set efficiently. Okay, that's why حتى ساعات بره بيعملوا ايه؟ They put some sensors to see if the cars are passing by. If the cars, they stop passing by, they can really change the timeout accordingly. So they change the timeout according to the time of the day, the peak hour of the day, and so on. Okay. So timeout has to be variable, has to change throughout the time. But changing this timer throughout the time is actually risky, because setting it to a value which is less than the appropriate value may cause unnecessary timeout events. Okay, and setting it to a time that's longer than appropriate may also waste the bandwidth of the channel if the acknowledgement was delayed. But in all cases, as we can imagine, even if we're talking about go back in ولا selective repeat ولا stop and wait, the timeout is very highly correlated with the round trip time. Round trip time معناه ايه؟ The time that a packet goes to go all the way to the receiver, and the receiver sends acknowledgement all the way back to the sender. ماشي؟ So this is the round trip time, which is the propagation delay forward and backward. ماشي؟ طيب هو اصلا الراوند trip time ده is it fixed? Of course not. It's not fixed. So we have to calculate the timeout based on a variable parameter, and we have to have certain estimation. طيب, should we set the timeout exactly as the round trip time? That's not advisable. So, as you can imagine, after this round trip time, we have to wait for at least يعني few nanoseconds just to be on the safe side, صح? طيب, how much time after this? So we have two variables now. We have the round trip time, which is dynamic and it changes, and even the time that we have to wait after the round trip time can also be variable. How much time we have to wait, we don't know. So what TCP does بقى is what it does is that it takes some sample measurements for the round trip time all the time. So whenever I send a segment and I receive acknowledgement, as we have done in the assignment, I can simply say the time of the acknowledgement minus the time of the transmission. I can estimate the round trip time, but this is a sample round trip time. Does that mean that this round trip time will remain like this? Of course not. Okay, but I can easily sample certain measurements of this round trip time. Do you agree? I can do that. صح? I can have many of these sample round trip time. Okay? But how can I use an estimated round trip time that's representative given many samples of this round trip time? So for that, TCP uses some kind of filtering. الناس بتوع electrical engineering, they know the filters. So they use filtering techniques, and the easiest filtering technique اللي هو اللي بيسموه ايه؟ exponential smoothing average أو exponential average. Okay, so we'll talk about this. Maybe حتى we can relate to next time. But this is the idea in general. The idea is that I take many samples of round trip time. I take these samples and then I perform some kind of filtering to smooth it out and to select like some average round trip time. But that's not the timeout. First, I need to estimate the average round trip time. ماشي? And then I take this round trip time and I add to it some estimated value برضو, اللي هي factor of safety يعني. Okay? And then based على estimated round trip time and this added estimated value, this will be the timeout.
Timeout exactly ولا lower bound بتاع timeout؟
لا, هو timeout بس, ما فيش lower bound و upper bound, لأنه when you fire the timer you have to set a timeout بس. خلاص, you have to set a timeout مثلا 3 milliseconds. خلاص, the timer will count down 3 milliseconds and then it will fire. Any change to that time معناها you stop the timer and restart it. خلاص, بس once you fire a timer with a specific timeout, the only way to change it is to reset it and then you restart it with the new timeout. ماشي. But that's what we are going to discuss. So how can we estimate the average round trip time from the sample round trip time? How can we estimate the added factor of safety that we have to add to the round trip time in order to calculate or to estimate the timeout? And all of this does not guarantee that this is the perfect timeout. يعني some people might use بقى reinforcement learning ولا حاجة زي كده to try to have some prediction and to use the best the best parameters whether estimated round trip time وكده for TCP. يعني I'm not sure if this is done, but I think it was experimented by some people. يعني. But this is the way, and it's experimental, it's empirical. There's no يعني مثلا mathematical proof that this is the best time out or this is the most efficient. There's no guarantee. ماشي? So we'll discuss it next time.